Chapter 10 is all about quadratic functions, graphing and solving equations with x squared in them. So first we're going to review how to graph a quadratic function. So we have y equals negative 2x squared, and since this is a pretty simple graph, I'm just going to make a table, an xy chart. And I'm just going to plug in 5 values, negative 2, negative 1, 0, 1, and 2. So if I plug in a negative 2 for x, I want to make sure that I square it first to get a positive 4, and then multiply it by a negative 2, so I get a negative 8 for y. If we square a negative 1, we get a positive 1, and then multiply it by a negative 2, we get a negative 2. If I plug in 0 for x, we're going to get 0 for y. If I take 1 and square it, I get a positive 1, and multiplied by a negative 2 is a negative 2. And then I will also get a negative 8 again. So, when we graph it, we will have a point at negative 2, negative 8. We'll have a point at negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. And when we graph a quadratic, it always looks like a U. So there we go. Moving on to the next graph, we see that we have a little bit more of a complicated function. Negative 2x squared plus 8x plus 5. Whenever you see 3 terms and you need to graph the quadratic function, we want to find the axis of symmetry first. We do not want to make a table for this one because that would be too difficult. So to find the axis of symmetry, we use the equation x equals negative b all over 2a. And our b is always the value that's attached to the x. So we're going to have a negative 8 divided by 2. Our a value is always the value in front of x squared. So 2 times negative 2. So we have negative 8 divided by negative 4. So we know our axis of symmetry will be x equals 2. So now we can take 2 and plug it in to find our vertex. So now we have y equals negative 2 times 2 squared plus 8 times 2 plus 5. So negative 2 times 4 plus 8 times 2, which is 16, plus 5. So we end up getting y equals negative 8 plus 16 is 8. 8 plus 5 is 13. So our vertex is at 2, 13. So let's start our graph. Vertex is up there pretty high at 2, 13. And then what I'm going to do is draw my axis of symmetry through my vertex, so I remember that that is the middle of my graph. The last thing I have to find is my y-intercept. Your y-intercept is always the number that's in the back of the function, your c term. So I'm going to put a point at 0, 5. And then I'm going to take that point and reflect him across the x-axis, or I'm sorry, the axis of symmetry. And that will create my parabola. And you only need to find 3 points for these types of parabolas. Find the axis of symmetry, plug that in to find your vertex, and then you use the last term to find your y-intercept, and then we just need to reflect it over for our complete graph. Now we will review solving by completing the square. So the first thing we want to do is take our last term and add him over to the other side. So we have x squared minus 14x equals 51. Now we take the middle term and we divide by 2 and square it. So 14 divided by 2 is 7. 7 squared is 49. So I'm going to take a 49 and I'm going to add it to both sides of my equation. Now we want to take x squared minus 14x plus 49 and we want to factor him. But remember, when we complete the square, he's going to factor into a quantity squared. So we do x, and then we take our middle term and we divide him by 2 again. And since it's a negative 14, we're going to have x minus 7 squared. And then we add 51 and 49 together for 100. Now we're almost done solving the equation. The next step is to take the square root of both sides to undo the square, because we want to get x by himself. So we have x minus 7 equals plus or minus 10. Because whenever we take a square root, we want to remember about the plus or minus. So now at this point, we can make two equations. X minus 7 equals positive 10, and x minus 7 equals negative 10. So then we'll get our two answers of x equals 17 when we add 7 to the other side, and x equals negative 3. For number 4, we want to do the same thing, except notice that there is a 2 in front of the n squared. So what we need to do is get rid of that 2. So we're going to divide everybody by 2. First thing. That gives us n squared minus 3n minus 4 equals 0. Now we're ready to complete the square. So I'm going to add 4 to the other side to get n squared minus 3n equals 4. And now we need to take the negative 3, divide by 2, and square it. The problem is here we're going to get some fractions. Because if we take 3 and we divide them by 2, we get 3 halves. And if we square 3 halves, remember to square the top and the bottom, you'll get 9/4. So we have to add 9/4 into both sides. So now we still factor it, and we're going to factor it as a quantity squared. In the middle, we're going to write n, and then again, we just take negative 3 and divide him by 2 again. So we'll have a 3 halves in the middle. And then to add 4 and 9/4 together, remember that you want to get common denominators. So it's good if we change the 4 into a 16 over 4. So 9 over 4 plus 16 over 4 will be 25 over 4. And now we're ready to take the square root of both sides so we can get n by itself. And here we lucked out because we could take the square root of 25 and 4. So we get n minus 3 halves equals plus or minus. The square root of 25 is 5 and the square root of 4 is 2. So plus or minus 5 over 2. Then we need to break it into two equations. N minus 3 halves equals positive 5 over 2. And n minus 3 halves equals negative 5 over 2. So if I add 3 halves, I'm going to get 8 halves, which is 4. And if I add 3 halves to negative 5 halves, I get negative 2 over 2, which is a negative 1. So 4 and negative 1 are two answers. Now we will review using the quadratic formula to help us solve a quadratic equation. So the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now the coefficient in front of m squared is our a, our coefficient in front of m is b, and the last number is our c term. So if we want to plug everything into the quadratic formula, we're going to have negative 7 plus or minus 7 squared minus 4 times 2 times negative 3 all over 2 times 2. So that will be negative 7 plus or minus the square root of 49. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is a positive 24. All over 4. So, let me zoom in a little bit. Get some more room. So that is negative 7 plus or minus the square root of 49 plus 24, which will be 73, all over 4. And that is the furthest we can go because we cannot simplify the square root of 73. And you will not have a calculator during the final, so this is the final answer for this problem. For number 6, before we use the quadratic formula, we have to set the equation equal to 0. So we want to subtract 5x and add 3 to the other side. So we'll have x squared minus 5x plus 3 equals 0. And now we're ready to use the quadratic formula. Since there's no number in front of the x squared, our a value is really 1. So we have x equals negative b, so positive 5, plus or minus the square root of 5 squared minus 4 times 1 times 3 all over 2 times 1. So 5 plus or minus the square root of 25 minus 12 all over 2. So x equals 5 plus or minus the square root of 13 over 2. And again, you won't have a calculator on the final, so this is the furthest you can simplify the answer without a calculator. For number 7, since there's only 2 terms, all we need to do is add 16 to the other side, divide by 9, and since 16 and 9 are both perfect squares, we can take the square root of that. So we'll end up with x equals plus or minus 4 over 3. And that's your final answer. For number 8, we're going to use the discriminant b squared minus 4ac to determine how many solutions this quadratic has. So negative 1 squared minus 4 times negative 6 times negative 5 is 1. Negative 4 times negative 6 is positive 24. Positive 24 times negative 5 is negative 120. So we end up with negative 119. Since the discriminant is negative, we know that we have no solution. This function would not cross the x-axis. If the number was positive, we would have 2 solutions, and if the number was 0, we would have 1 solution.